Next is, let us apply inverse transform technique to triangular distribution. Now till now this Weibull distribution, uniform distribution and exponential distribution, these three distributions had only one equation for uh, probability density function small f of x, but in triangular distribution we have two equations. So probability density function small f of x is equal to x, where x is between 0 and 1. Whereas for probability density function for triangular distribution small f of x, for x value 1 to 2 is 2 minus x. So here I have, for this range I'll have probability density function x, and for the second range 1 to 2 I'll have equation 2 minus x. So how to deal with such problems? So first let us generate a random variable equation for random variable for only this equation, and then let us go for this range. So first, if I have to go for this range for this equation, let us consider small f of x, that is probability density function, is equal to x for this range 0 less than or equal to x less than or equal to 1. So cumulative density function, as usual, capital F of x is integration of probability density function in terms of t, where lower limit is 0 and upper limit always will be replaced by x. So 0 to x integration of f of t dt. Integration of f of t dt 0 to x is nothing but, so f of x is x, so x is replaced by t, so t dt. So integration of t is t square by 2. Lower limit is 0 and upper limit is x. Replace this t square by lower limit and upper limit. So it is x square by 2 minus 0, that is nothing but x square by 2. Equate this equation to capital R, that is random number. So x square by 2 is equal to R. X square is equal to 2R and x is equal to square root of 2R. So this equation, the limits are 0 to 1 by 2. How do we find these limits for R? Apply lower limit 0 in this equation, x square by 2 is equal to R. If I apply 0 here, what do you get? R is 0. Whereas apply upper limit 1 to this equation, that is 1 by 2. So R will have values 0 to 1 by 2. Apply these two values in this equation, you are going to get lower limit and upper limit. So x is equal to square root of 2R for 0 less than or equal to R less than or equal to 1 by 2. This is for the first part. Second part, f of x is equal to 2 minus x, where the range of x is 1 to 2. 1 less than 2 less than or equal to 2. For this CDF, cumulative density function, as we have already discussed that cumulative density function is summation of all the previous probability density functions. So capital F of x for the second range is always summation of probability density from the first range 0 to 1 and second range 1 to 2. So here first I am going to take from 0 to x. This 0 to x I am going to divide it as 0 to 1 and 1 to x. Upper limit always should be taken as x, right? So 0 to 1 and 1 to x, because 0 to 1 I have a different probability density function equation, and from 1 to 2 I have a different probability density function equation. So that's why I am going to take two times. One is first one is from 0 to 1 and the second one is from 1 to x. So here what is the equation you get after integrating? You are going to get x square by 2, right? So the same thing I am going to write, f of x, f of t dt for the first range is x. Equation is x here, x, right? So the same I am going to write it here, t dt plus second one equation is 2 minus x. So 2 minus t dt, where lower limit is 1 and upper limit is x. So t square by 2 After integration, it is t square by 2, lower limit is 0 and upper limit is 1. Here I am not going to take it as x, I am going to take it as 1 as it is, plus integration of 2 minus t. 2 is a constant, so you are going to get it as t minus t square by 2. Lower limit is 0, upper limit is x. Here only I am going to take the upper limit as x. So 1 by 2. After substituting all these upper and lower limits, I am going to get this equation. 1 by 2 plus 2x minus 2 minus x square by 2 minus 1 by 2. So after solving all this equation, I am going to get x is equal to 2 plus square root of 2 minus 2r. Now, for which range will this equation work? This equation will work for 1 by 2 less than r less than or equal to 1. Where should I substitute this equation? This values I have to substitute 1 and 2 values in this where I have equated to r. Here in this equation I am going to substitute values for x, that is 1 and 2. First substitute 1 here, you are going to get 1 by 2. Then substitute 2, you are going to get 1. So 1 by 2 less than r less than or equal to 1, because here we have 1 less than x less than or equal to 2. See here less than symbol is there. So here also I am going to use less than symbol. This is the equation for triangular distribution.